Hello, welcome to example 3 in our functions and graph topic. We're looking at inverse functions. Hopefully you've watched examples 1 and 2. If not, go back and watch them first of all. So we're looking at algebraic inverses, and in this example we're looking to find the inverse of the function f of x equals negative 1/8 x cubed. So hopefully that you know by now we're looking for to write down the original function, preferably with a y instead of f of x. And in order to find the inverse, we can say that it's going to be based on the idea of swapping around our x and y values. So let's do that. X goes on the left and y is going to go here, and we've got negative 1/8 y cubed. So x is equal to negative 1/8 y cubed, and we're going to rearrange to make y the subject of the formula. So we're going to multiply by negative 8. That would probably be a good way of getting rid of the negative 1/8. So we get negative 8x is equal to y cubed. Then what we're going to do is take the effectively cube root of both sides. Cube root of both sides. If I did it like that, then what we'd end up with is y on its own here. Cube root of y cubed is y, and we end up with something that looks like this, the cube root of negative 8x. Now interesting, you might think, oh, a negative number under a root sign, but of course it's a cube root sign. And so if we were to split that up into the cube root of negative 8 multiplied by the cube root of x, you might remember that negative 8, the cube root of negative 8 is negative 2. And so we end up with that expression here, y equals negative 2 times the cube root of x, which I'm going to rewrite because I was asked to find the inverse function. I'm going to rewrite with a wee inverse function notation here. And there is my inverse function. Again, we could check algebraically. One should cancel out the other if I were to substitute that in, which I'm not going to go through, but that will all cancel out and give us back to x. Suitable domain and range for our inverse function. Well, let's have a wee think. Any values of x that we can't put into a cube root function? Well, unlike the square root, of course, we can have negative values of x in there. So there aren't really any values of x which would not be able to give us a numerical value. So we could say that effectively x is just, we need the set of, x is going to be from the set of real numbers. The range, well, okay, are there any limiting values? Nope, the cube root of x will be either negative or positive multiplied by negative 2. Nope. So we could say that the inverse function, again, is not going to have any restrictions to it. So we can just say that it's going to be any value of the set of real numbers. Okay, so that's us finding the algebraic inverse. We're going to look next at the idea of finding the inverse graphically, which is a slightly different process, but hopefully that's been of interest to you.